Voltex Spark. This is going to be the first video that I do on the automotive EV industry, and my main intention with these videos on this channel is to tackle the amount of misinformation that is being spread on this subject, whether it's battery electric vehicles, hybrid electric vehicles, or fuel cell electric vehicles. I really don't like the amount of misinformation that is being spread. I don't like the incorrect opinions that are brought up every time. And I really want to just address comments and misinformation in the most automotive mechanic way that I possibly can. So since this is one of the first videos of the channel, definitely the first major video of the channel at an hour long, first I will establish my background and basically what gives me the idea that I have any authority to speak on these subjects. I have been an automotive technician for the last 10 years. I went to Texas State Technical College for my associates in automotive technology. I am dealer certified in Honda, and I'm working on fast tracking my way through Fiat, Chrysler, Dodge, Ram, Jeep. Although I'm not a Chrysler, Jeep, Dodge, Ram technician, I work on all of the other makes that the specific dealership that I'm employed at sells. That includes Tesla, Rivian, Lucid, any EV or hybrid that you could think of, I work on quite frequently. I am a level A diagnostic technician, which means if there is a problem, I am the one that does the diagnostics. I have the special tools, I have the special equipment, and I have the experience to be able to do so. So when I talk about these subjects, it's not from a position of theory. It is from a position of this is what I do every single day. This is how I keep a roof over the heads of my kids. This is how I keep food in their stomachs. This is how I pay for all of the things that I enjoy doing. Very expensive things like RC planes, pew-pews, motorcycles, video games. The computer I'm making this on, I have 2 monitors. It's very nice, very powerful computer. I don't really know what that has to do with anything other than to just say I make a very decent living, 6 figures a year, doing what I do. So I do believe that I have a very, very strong foundation to be able to discuss these things and have an opinion. With that being said, this video that I'm about to tear apart, mind you, it is a 12-minute video that I take an hour to dissect. There's a lot of information. I give a lot of information on this video. So if you're curious as to how these systems work, how they're going to work, how they work in theory, where they come from, a lot of that's in this video. If you're curious, watch it. You stand to learn a lot. You stand to gain a lot of knowledge. The other thing is I don't intend to be mean, rude, condescending. It sometimes just happens. Like I said, I've been a mechanic for 10 years. You would not believe the amount of shop talk that goes on and what it sounds like. This is extremely tame. So without further ado, let's get into the video, get out of the intro section, try to make this as short as possible. So here we go.
Stupidity that is beyond imagination. Where am I going with this? All right. So obviously everybody's going electric. Everybody wants electric trucks, right? The Lightning and the Rivian and the Tesla, the Cybertruck. Great, you want electric trucks? Have electric trucks. So naturally, Dodge has to do a Ram electric truck. And they're going to call it the RamCharger. Haha, cute play on words, right? All right. And the Rev, right? The Ram electric vehicle. Another cute play on words. Great. All right. So I don't care if you have.
Let's also start with the Hornet. The Hornet is planned on being offered as a hybrid and a full battery electric by Dodge. So it's just not super important, but it's another fact that we can't ignore here.
Have electric trucks? Have electric trucks. If somebody can use the electric truck, more power to them. So when I first hear about the Ram RamCharger, I hear that
he was discussing just the trucks. Got it.
news is that it's going to come with a range extender. All right, a range extender. And what is this range extender? Well, it's a gasoline-powered generator. And I say to myself, when I hear about this is a while ago, it's like maybe 10 months ago, I say to myself, that's a cute novelty. Like, if I was going to invest in an electric truck, if for whatever reason I felt an electric truck suited my lifestyle, right, was suitable for purpose, as the British say, which is like, that's one of my favorite terms, suitable for purpose, then yeah, you know what? Having an onboard electric generator would pretty much eliminate a lot of range anxiety, because it's like, okay, well, I can't find a charging station. Let me pull over here and fire up the generator. And in my mind, I'm saying to myself, well, within this pickup, which no doubt is going to be huge by large, by bigger than anything reasonable, within this truck, they're going to have a compartment, and it's going to have something like, like a Harbor Freight type of generator, like a small Honda generator that you could fire up and sit on the side of the road for an hour and, I don't know, scroll Facebook while you get enough charge to get to a place. Okay, you know what? All right, this is a pretty cool novelty. I like that. That's it.
So you can kind of already see here, there's a lot of confirmation bias in his approach to how a range extender would work. And it comes from a place of ignorance as to how these systems in general function. Comes from a place of ignorance on how hybrid electric vehicles have functioned in the past. And a perfect example is one of the comments was discussing that the RamCharger works exactly like a diesel locomotive, which it does. A diesel locomotive has a V16 diesel engine. The diesel engine is only connected to a pneumatic air pump and an electric generator, a very large electric generator. Now, if you look at a diesel electric locomotive, you will see it's got the engine compartment, flares out to a walking railing kind of pad, and then it skirts down. Now, on like a lot of the Union Pacific trains, they are painted orange, and then that bottom skirt is painted black. In between the bottom skirts is an array of nickel metal hydride, traditionally nickel metal hydride battery packs. And the battery packs were used to store power for bursts of acceleration. Like when the train was leaving the station, the diesel engine would tick up to its operating RPM, which we'll discuss why they have a very specific operating RPM here in a minute, which I did explain in my comment on his video. I commented before I listened to this bullshit. That battery pack is used to supply additional power to the electric motors. That V16 diesel engine does not physically connect to the drivetrain in any way, shape, or form. It powers a pneumatic air pump, which operates a lot of the car safety systems. It operates the air locks on the hitch pins, and it operates the air brakes. The generator portion that the diesel engine is attached to powers the wheels. The wheels use electric motors, which get their power from wires connected to the batteries, which is connected to the generator. That's how a diesel locomotive works. That is also how the RamCharger works. It's really fucking simple. And a lot of people will say, well, then why can't the diesel electric locomotives power themselves without the diesel engine running? A lot of that is because of the battery chemistry being nickel metal hydride. With batteries, there's something called a C rating. The C rating is how much you can charge or discharge a battery, how many amps you can pull from that battery before cooking the chemistry. Nickel metal hydride has a very, very low C rating compared to the nickel or lithium iron phosphate or lithium nickel metal cobalt. or nickel manganese cobalt that we have. Those battery chemistries have very high C ratings. Nickel metal hydride has very low C ratings. The reason why they can't pull off on battery power alone, and they actually can if you remove the lockout, is because the batteries just don't have a high enough C rating to actually do it. And a rail operator can come and correct me and say, well, when the engines are empty, we just idle the diesel engine and use just the battery power. If that's the case, come and correct me. Cool with that. Let's continue.
Advanced thought. And, okay, but no, you see, no. It can't be anything that simple. It can't be anything that easy. It can't be anything that obvious or logical. No, nothing like that. So what I found today is that the new Ram Charger, the REV, all right, electric vehicle, comes with an onboard gasoline-powered generator, as expected, but it's not a little Harbor Freight type of, pull the cord and let it charge. No, it's nothing like that. Not even an electric start generator, like the next step. No. Like, this is just too hard to even put into, like, I just gotta spit it out. The generator, the electric generator on the REV is a 3.6 liter V6. It's a 3.6 liter V6. Okay? This isn't like, all right, your emergency no. It's got a full house 3.6 liter V6, a regular automotive engine. That's the generator, the backup generator, the range extender for this battery vehicle.
Yes, it's a established engine that FCA has 20 years experience with currently. Yes, it's a full-size engine because this isn't your pissant 9 kilowatt generator that you've got in your shed for when the power goes out for your house. This is a 20 kilowatt generator, okay? This produces 20,000 watts of power at, I believe the battery voltage on the RamCharger is 600 volts. Understand, let's do the math here. You could ask him to do the math. I don't know that he would know the equation offhand. I'm pulling up my calculator. So if we have 20,000 watts and we divide that by 600 volts, we get 33.33 amps. If we take 600 volts, multiply it by 33.33 repeating, we get 20,000 watts. That's how Ohm's law works, in case you were wondering. So we have a onboard generator that can produce 600 volts plus at 30 amps plus to charge the batteries on the RamCharger. Now, a lot of people that I've talked to go, well, why? I can plug my Tesla into the wall and the wall power is 120 or it's 240. How does that charge the vehicle? Well, it charges the vehicle by use of inverters. And I'll have to look up the technical specifications at work and see if it's actually charging at 600 volts or if it is involving an inverter system, which from what I've seen, I don't believe that it is. I believe that it is charging natively at battery's voltage. But when you plug your Tesla into the house at 120 volts, we'll say, the circuit is limited to 15 amps. Your inverter in the vehicle now has to take 120 volts and step it up to, it depends on which model you have. We're going to use 450 volts as just an arbitrary number right now. It's somewhere between the 400 and 600 volt range for Tesla Model 3. Don't know off the top of my head. I'm not a Tesla technician, even though I do work on them. So we're taking 120 volts at 15 amps. That's 1,800 watts. That's 1.8 kilowatts. So level 1 charging, you're charging at 1.8 kilowatts. Now, you could take a 2,000 watt Honda generator and charge it with a 120 volt plug, and that's kind of where he's going with all this. And it's just idiotic, because that's what he's expecting. He's expecting you to pull out like a 2,000 or 5,000 or or 8,000 watt generator and plug it into the RAM and charge this insanely massive battery pack that uses 5 times, it's like 4.5 to 5 times more voltage than your house provides on a standard outlet. He expects you to pull this generator out of the back or start it up like an RV, like an Onan generator on an RV, to charge the battery pack while you just hang out and wait. That is flawed logic. That is the core definition of flawed logic. Yes, I'm going to pull my truck to the side of the road and I'm going to use a 2 kilowatt generator to charge my, I believe they're using an 86 kilowatt hour battery pack. That's the definition of stupidity. I'm sorry if that offends you. It is the damn truth. It's the definition of stupidity. So yes, it has a 3.6 liter in-house Pentastar V6 because it spins a 20 kilowatt hour generator. And he'll go into some more of this in a minute that I want to tear into. But here's the thing about gasoline engines. If you have an engine that can produce 600 horsepower, okay? This engine can produce 600 horsepower, but it uses 3 gallons per minute to produce 600 horsepower. If you only need it to produce 95, 100 horsepower, it's going to use significantly less fuel. It is not a linear equation either. It is an exponential equation. The higher the RPM and the more horsepower, the more fuel is needed. The curve looks like this. So when you're all the way up here and you're using 3 gallons per minute and you need to come down here to where you use maybe 0.3 gallons per minute, 0.2 gallons per minute, that's what they're doing with this V6. It's not running full tap, wide open throttle to generate this power. It's running just a little bit, just at a nice level, economical, good RPM to where it can spin that 20 kilowatt generator, 20,000 watt generator, and produce enough electricity to refill the battery pack and spin the wheels of the vehicle. Anyways, let's move on. This video is getting fucking long.
Can we put this in perspective for a second now? They're going to put, okay, so
I just did put it into perspective. I apologize that your perspective is skewed because you don't know what the fuck you're talking about.
the whole goal here is to eliminate the internal combustion engine and go with battery power. Okay, that's where you want to go.
That's not the goal, though. The goal is to find a drivetrain that is more efficient, meaning less pollution. That's the entire goal. The whole hybrid and EV movement has three goals in mind. The first, reduce carbon emissions. Because it doesn't matter what you believe, it doesn't matter if you believe in climate science or not. Factual data shows that humans have had a direct effect on the increase of CO2 particulate in the atmosphere. There are a lot of other things other than the climate that does mess with. So, ignoring climate science as a whole, we're throwing climate science out the window for this argument. Reducing the carbon emissions and reducing the ppm of CO2 in the atmosphere benefits everybody in a lot of different ways. I mean, the most basic thing is if you like food, bees pollinate crops. Crops produce, like the crops create your food. Bees pollinate those crops. Bees can't live in a CO2 rich environment. So we kill the bees with a very high part per million of CO2 particulate in the atmosphere, well then you don't get to eat good shit anymore. You get bug protein. That's really fucking good reason to reduce the CO2 in the atmosphere. So I don't want to eat protein bars made out of cockroaches and ants. Reason 2 is to reduce the impact of oil consumption. Because think about it, everything we make is plastic. My phone has plastic in it. These monitors are made of plastic. This camera is made of plastic. My headphones are made of plastic. There's plastic in my cereal. There's plastic in my Monster can. There's plastic in my wallet. There's plastic in my whole thing's plastic. All of this is plastic. His lenses actually do look to be glass, so I commend him on that. Those are fucking expensive. Everything's made out of plastic these days. What is plastic? It's a petroleum byproduct. What is petroleum? It's what we dig out of the fucking ground to make gasoline. So if we can reduce the amount of gasoline that the world uses, we can divert that petroleum to other industries to continue making the things that we enjoy day to day. The third reason is because, and this is a controversial one, this is one that I believe is the third reason, but maybe not everybody does. The third reason we're moving to hybrid and electric systems is because engine technology has kind of run its course. There's not a whole lot that we can discover left in the internal combustion engine that would make it more efficient and get the first two things out of this progression of technology. Cummins and their work on the opposing piston engine, specifically with the ACE, the combat engine program, that has some hope, but those just make ridiculous amounts of horsepower for a lot of fuel. Nissan has done some work with variable compression engines that essentially increase the stroke of the piston to alter the compression ratio, and it's promising. They've done over 1 million miles of testing in Japan with these engines. They've given them to customers, but its end result's not a whole lot different. You get a largely more economical engine, but it'll never come to America because America is a society of people that think their minivan needs to be able to do 120 miles an hour and get there relatively fast. I could talk about that for a long time. Let's continue.
But in this vehicle, they're including a full tilt automotive V6. Now, all right, you say to yourself, well, the V6 is only going to run for short periods of time to recharge the battery. And
it's not just about it running for short periods of time. It's about it running at very, 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 very low loads, which means less fuel.
In theory, that's probably how they intend it to be. But, you know, the reality is people are going to run the battery down and just have the gasoline motor running all the time. But that's besides the point. All right.
Also not how it works. It doesn't trickle charge the battery. It throws 20 kilowatts of power into the battery. Make it make sense. Make it make sense. Make it make sense. How are you this dumb?
All right, so picture this. So not only do you have a full tilt truck powered by batteries, and it's got its battery pack, and it has dual electric motors. There's one in the front and one in the back, and one in the front is detachable for efficiency's sake, which makes sense.
So it's not detachable. Jesus fucking Christ. Electric four-wheel drive systems don't work like conventional four-wheel drive systems where you're engaging and disengaging a gear set to spin a propeller shaft. It works by not supplying power to the fucking motor.
You've got all of the electronics, all of the controls that go with the battery power setup.
A modern PCM, powertrain control module, they're not called engine control modules anymore. They haven't been since 2016 when every single manufacturer made the switch over to the CAN bus system, which is a high-low binary code system, uses frequencies to communicate between modules. No one has used an ECU since then. It's been a PCM because it controls the entire powertrain control module. If you were to spread it out on a graph, which a lot of scanners are starting to do this, you'd have the powertrain control module. Then you'd have a line going up here, and you'd have the body control module, the window control module, the radio control module, the navigation control module, the air conditioning control module, the security control module. And you'd go over here, you'd have the drive systems, the ABS control module, traction control module. All of these different modules all send data back to the PCM. So this is where his experience in new vehicle is obviously complete and totally devoid, gone, just not there, because it would still take just the one PCM to run both the gas engine and the battery electric system. It would be the same thing, be the same computer, the same chip, the same brains. Dodge PCMs actually have a ton of excess room where they could add interfaces for all of these different systems. And it doesn't matter because everything on the vehicle is going to have its own CAN bus module, period. It's already going to be there. So now we're adding a battery management system control module, a inverter system control module, and a few other things. It's just, it's a dumb take.
Okay. And then you have the V6.
Oh, I cannot wait for this. I cannot wait for this. This is going to be fun.
Why did he tell us?
So just to put this in perspective now, let's go over to this Jeep. So in order to run the generator, the 3.6 liter generator, you need everything that's under this hood, in addition to the battery. So you need the actual...
Okay, so even without the engine, I can go out to my Nissan Leaf and show you guys this. I still have a brake fluid reservoir. I still have a coolant reservoir. I still have a window washer fluid reservoir. I still have a power distribution block with fuses. I still have a relay control center. I still have a 12-volt battery because you're not magically going to make 12-volt automotive shit work on 400 volts. It's not how electricity works. Just more stupidity.
engine itself. And a 3.6 liter V6 is not something that just, okay, well, obviously the straight six is a different deal, but just for illustration purposes, it's a full-size engine, okay? So that's...
It's a small engine. A lot of people don't understand how compact the Pentastar is, okay? Let's take a Honda Civic 1.5 liter Eco Dreams inline 4 and put it next to a Pentastar V6. We're going to have the exhaust manifold hooked up and the intake manifold hooked up on both engines. The Honda engine is physically larger. It has a larger volume, as in if you took the engines and you dipped them in a tank of water and you measured how much that water level rose, the Civic engine would take up more physical space than the Pentastar would, because the Pentastar is designed, V6 engines in general are designed much more... You okay?
Yep.
Okay. We're all sick. V6 engines are designed in a much more space-effective way. So, just adding a list. I'm gonna make a fucking whiteboard and...
That's part of it. It needs its own injection setup. It needs a fuel tank, it needs a fuel pump, it needs fuel filter, it needs everything that's here to run the engine.
And a generator doesn't? I'm sorry, how do you think generators work? They have a cooling system, whether it be air or water. There are water-cooled generators out there. They have their own cooling system. They have their own fuel tank. They have their own fuel injection system or a carburetor. Most of them these days are fuel injected. They have their own oil system. They have their own evaporative emissions system. It is required by law for all small engines to have an evaporative emissions system on board. They have their own ignition system. Some of them get complex enough to have their own belt system, but you're up into the $13,000 to $20,000 range for a home generator that's contained in a box.
It needs its own ignition system, obviously. It needs its own exhaust system. It needs its own cooling system.
Again, do you think that generators don't need an exhaust system? That's what you're implying here. You are implying that a generator, like a genset, like a 9,000 watt generator from Honda, doesn't need an exhaust system, doesn't need a cooling system, doesn't need an ignition system, doesn't need a fuel system, doesn't need a way to store fuel. You are implying that a generator, like you said, apparently according to you would make sense, you are implying that they don't need these things. They absolutely do. And here's what's fun. Guess what is physically larger than a Pentastar V6 engine? A 5,000 watt generator.
It needs everything you see here. It needs a water pump. It needs everything you see here to maintain this strict.
Something like 80% of vehicles these days come with an electric driven water pump. Just FYI.
Gasoline powered vehicle.
My Leaf has an electric water pump and a radiator and a coolant reservoir. What?
Nothing.
You're adorable.
Nothing.
Yeah. My Leaf has all these things. Electric water pump, water hoses, doesn't have a heater core because it uses a resistive system to generate heat. Just dumb points.
It needs all of that to run the battery charger. So you've literally got every bit of componentry and complication of an EV, along with every bit of componentry and complication of a gasoline-powered vehicle. All
Except for you don't, because the gasoline engine isn't running under high load. It doesn't run high RPM. It just doesn't, because it doesn't physically drive anything on the vehicle other than a generator. It spins a very, very, very large 20 kilowatt alternator, essentially.
combined in one package. How many failure points can you put between two bumpers?
How many failure points are already between two bumpers on modern vehicles with emissions control systems, exhaust gas recirculation, evaporative emissions, safety features, safety protocols? The only thing you're adding here compared to a standard series parallel hybrid electric vehicle like a Toyota Prius or Ford Fusion or literally anything, and mind you, plug-in hybrids do not function like this. Plug-in hybrids, the gasoline engine is physically connected to the wheels in some way. A Toyota Prius plug-in hybrid still uses the same engine and transmission basic setup as they did in 1997 when the Prius was first released. It all works the same until the RamCharger. The only other vehicle that works like the RamCharger does at a series hybrid level is the Fisker Karma EcoSport. That had a 2.2 liter Chevy Ecotec engine that spun a generator.
Because that's what this is. That's what this is. It's one giant failure point from one end to the other. People will buy this.
This is where his ignorance comes in. This is the difference between him and somebody that's actually worked in the automotive industry for the general public within the last 25 years. I can't explain it without being insultive right now, so I'm going to move on.
People, because they don't know any better. But the people who...
He doesn't know any better. He's being hypocritical right there. He knows jack shit about series hybrid technology.
design this do, the people who design this do, they're literally sending failure out into the world.
Except for here's the thing. If something on the Pentastar in the RamCharger breaks, the vehicle does not become inoperable. If something on his Jeep breaks, if the accessory drive belt snaps, he can no longer continue to drive the vehicle under normal circumstances. If the V6 engine on the RamCharger dies, big fucking deal. I just have to go find a charger now. Woo! Who fucking cares? Battery electric systems don't typically break. They have a significantly lower failure rate, and I know everybody likes to say that they're fire magnets and they're fire danger and they catch fire more than ICE vehicles. They don't, not by a long shot. They're extremely reliable. So at the end of the day, you're adding an optional accessory that if it breaks, it doesn't affect the overall operation of the vehicle. That's his lack of understanding as to how this stuff works. He doesn't know what he's talking about.
Because there's no way that these things can maintain themselves for anything more than, let's say, the warranty period, and that's self-destruct.
Just further proving my point that he has absolutely no clue what he's talking about. Like, it blows my fucking mind. What does he think? That every single FCA vehicle that has a Pentastar that has been sold in the past 20 years, does he think that after the warranty period they've just magically went boom? No, they haven't. There's still more than 80% of the examples on the fucking road today.
It's impossible. There are too many points of failure. Every time.
I'm pausing so frequently right now because of how little he actually understands about this stuff. You're not adding points of failure. Just period. You're not. You're arguably making a more reliable system because you now have a battery electric vehicle that can charge itself while driving, and it can charge itself while also powering itself with the charger that's charging the battery back.
Time you add another complication to the machine, you add another point of failure. This thing has failure. It screams failure all over it. It's,
again, more proof that he hasn't worked in a dealership or a shop that's open to the general public in way too long.
It screams waste all over it. Okay, so I know what a lot of you guys are thinking right now. This guy's a moron. How is that any different than a hybrid? A hybrid has all of the things that this truck has. How is that any different? It's completely different.
It's not. A hybrid actually has more things than this truck does. It has a very complicated and expensive inverter system.
The hybrid can justify its complication, its extra complication, can barely, but it can justify its extra complication by the fact that when the battery is dead, you can motor on.
You actually cannot. That is a misconception. When the battery system fails on a hybrid electric vehicle, doesn't matter if it's a Toyota Prius, a Honda Ioniq, a Hyundai Ioniq, a Honda Clarity, Honda Civic hybrid, Honda Accord hybrid, Toyota Camry hybrid, Toyota Sienna hybrid, doesn't matter. When these battery systems fail, because of the inverter system, because the electric motor is physically a part of the transmission, I don't know where they think these new hybrids that have been coming out for the past 15 years, 97, more than 20 years. I don't know where they think the electric power is going, but it is a electric motor, typically a planetary gear drive system built into a rotor, and then the stator goes around the planetary gear, and the stator uses high frequency to spin the rotor, which is now the planetary gear set. It's typically how most of these work. For example, the Toyota Prius, the crankshaft on first two generations, the crankshaft connects to a clutch. It is a solenoid actuated clutch. The clutch connects to the input shaft of the transmission. On that input shaft inside the transmission, there is a rotor. Around that rotor is a stator and a planetary gear drive on the back side of that rotor. That planetary gear drive outputs to another rod that goes to another rotor for a different motor generator, which also has a stator going around it. So there's two motor generators. On the outside of the second motor generator, there is a ring gear. There is a chain that connects that ring gear to the differential, and then the differential goes to the tires. That is literally every single major component inside a Toyota Prius transmission from 1997 to current 2025. That's how they work. The two motor generators using the engine output are varying the speed. That's how it gets the CVT. That chain does not vary. The motor generators cause that variation through the planetary gears to the front wheels. That's why Priuses don't have a high top speed, is because essentially it's a fixed gear ratio. So you physically cannot drive the car if the battery does not work, if the inverter does not function. You cannot drive the car up past maybe 25 miles an hour because the vehicle can no longer articulate the constant velocity of the transmission. It can't variate the output of the transmission because it uses the electric motors to do so. On Hyundai and Honda, the newer hybrids, you can literally undo a plate and pull that entire assembly out of the transmission and try to drive the car. It won't go anywhere because it is a functional part of the transmission.
The internal combustion engine. A hybrid. Okay, it's both systems all wrapped up into one package, and they'll both function to move the vehicle. Not on this thing. On this thing, the 3.6 liter V6 is only used to power a generator. There is zero connection between the internal combustion engine and the wheels of the vehicle.
It's the first thing he said that's actually correct. All it does is spin a 20 kilowatt generator, and the word choice he's using makes me still think that he has no clue what he's talking about. Because if it fails, then big fucking whoop.
It's absurd. It's absurd. It's only used as a battery charger. Why did they do this? Why did they do this? Because it's a play on gullibility.
They did this for the same exact reason that Ferdinand Porsche did this beginning in 1939 when he started designing the Elephant tank destroyer. They did this for the same exact reason that Ferdinand Porsche used a series hybrid system on the Tiger Porsche when Hitler asked for a new heavy tank. I know everybody gets sensitive when you bring up Hitler, but they were on the forefront of technology. Deal with it. The whole point of the series hybrid system is I can accelerate using the power created from the onboard power adder. I can accelerate with the electricity coming directly off of that generator while that generator simultaneously charges my battery pack. That is why they did this. Literally, that is the entire reason. Effectively, if you want to get very specific, what the 3.6 liter Pentastar V6 does on the RamCharger is it increases the C rating of the battery pack. Remember, C rating is a rating at the rate a battery pack can charge or discharge. So if you're limited at discharge current with your battery pack, now we have a gasoline-powered range extender. Well, now we can funnel the maximum amount of energy that the batteries will discharge into the electric motor. And then we can take the electric power created by the gasoline engine, which is running at low load, low RPM, and put it into the wheels. And we can get very, very impressive power output to the wheels from the electric motors. That's kind of the entire intention of this. And it is vastly different and vastly superior to the series parallel hybrid systems that have been in use for the last 25 years.
To play on the gullibility of the public. Because the market that they're moving into with this truck is electric trucks. So the Cybertruck, the Rivian, the Lightning, all of these other trucks, right? The electric trucks.
One thing that he has completely, utterly failed to mention this entire time, which I could have honestly just stated this fact and then he'd be done, but I kind of wanted to tear him a new one. The RamCharger has a range of 700 miles. Okay? The Ford F-150 has a range of 200 something. The Rivian has a range of 300 something. The Cybertruck has been shown to have a range of like 200 something. The RamCharger has a range of 700. Yeah, they're just fucking playing on gullibility. They're trying to get a dime off of how stupid people are. I don't know what the fuck I'm talking about, and I refuse to look at numbers that actually add to the story. Oh, okay. Well, I guess it was the one where you don't know what you're talking about.
So if it's going to be an electric truck, it has to be an electric truck. It can't be a hybrid. And
it is an electric truck. You have the option on the RamCharger to never use the Pentastar. You have the option on the RamCharger. It's a setting that you can change as you go. You can set it so that that V6 engine never once turns on. You can put 100,000 miles on the truck and never, ever, not once use the engine.
So there's no connection between the engine and the driveline of the wheels. The hybrid justifies itself barely, and I mean just barely. The hybrid justifies.
I don't know, a 2023, 2024 Honda CR-V Touring Hybrid gets an average of 43 miles per gallon real world. A 1.5 liter turbo Honda CR-V gets 23 to 25. I don't know what your definition of barely justifying is, but I don't believe that it's correct, just like everything else.
Justifies itself by the fact that it can use both.
No, you, again, cannot use both. It's not either or. It is always both. Does not matter what you're doing. Does not matter what speed you're going. Does not matter how you are accelerating in a series parallel hybrid electric system, which is, mind you, everything else out there. You are using both all the time at every time.
Or simultaneously, you can use both at the same time. This can't. This is a battery vehicle with a complete automotive engine and everything that goes with an automotive engine, a catalytic converter, oxygen sensors, you name it, it's all in there, but it's only to run it as a battery charger.
And now we get a little bit more information. He's assuming that that gas engine will only run when you need to charge the batteries. That's not the case. It will, as you drive, recharge the battery pack and power the wheels while using very little fuel and not putting a load on the engine.
How ridiculous is this? Why did Dodge even stop there? Why don't you throw twin turbos on this thing so you can have a twin turbocharged 3?
They're doing that with all of the other Rams and the Challenger and the Charger and a few other vehicles. It's the Hurricane i6. It's a beautiful engine. If I can't get my hands on a RamCharger through the dealership that I am a level A technician at, I will be getting a Ram 1500 Laramie with a Hurricane i6 twin turbo.
3.6 liter V6 battery charger. You got to see the pictures of these things. They're huge. I mean, pickup trucks have gotten bigger and bigger and bigger. It just is like it's a never-ending thing. They just keep getting bigger. This thing is.
You can thank American society for that, because people have convinced themselves that they need a bigger vehicle to go to and fro. Honestly, the RamCharger will be purchased more by insecure guys who really want a minivan but don't want to be seen in a minivan. That's going to be the number one purchase. We're purchasing one because we spend literally every weekend in the woods, fishing or hunting or camping. And I just really want a truck for that. Do you understand how awkward it is driving an electric like Nissan Leaf or Tesla 3 into the woods to go camping? It's dumb.
They show it in front of houses. They show one in a driveway in front of it. If they show one in a driveway, it dwarfs a two-car.
Mind you, in this picture, it does not dwarf a two-car garage, okay? NHTSA, National Highway Traffic Safety Administration, governs a lot of different things. Governs the allowable width of a production vehicle. There is a hood height governance on the vehicle. The average lane, the minimum requirement for a lane in the United States, a lane of traffic, is it has to be 12 feet wide. This is not wider than 12 feet. Okay, this is not bigger than a Ram 1500 that you can go pick up off the lot right now. What they're doing here is called framing. Okay, so they're using a type of lens with a aperture setting that allows for greater depth of field to make it look more stand out. You know, they're creating a very distinct difference between the background and the foreground. Obviously, the house and the garage is the background, the truck is the foreground. That's why it seems to be massive. It's not. This is absolutely no bigger than your typical Ram 1500.
Our garage behind it. It's giant. It's giant.
Also, the fact that he somehow has convinced himself that a automotive manufacturer could sell a vehicle that is wider than a standard lane for traffic tells you all you need to know about him.
Dodge, Why not give the people something that's actually efficient? Why not put a
Again, talking about shit he has no clue on. This is the most... God, boy, you sound horrible. This is the most efficient powertrain ever conceived by humankind. Period. End of story.
a nice, efficient four-cylinder engine in, let's say, a first...
Four cylinders are not efficient when it comes to doing truck things, okay? They're not. Here's the thing with engines. If you create a four-cylinder engine that makes 225 horsepower, and you create a V8 engine that produces 1100 horsepower, now, both of these engines only ever need to use 225 horsepower. So the four-cylinder engine that you've created, it produces 225 horsepower. You don't need to limit it. This 1100 horsepower V8, you limit it to only produce 225 horsepower electronically. And you put them side by side in the same exact truck, same features, same GVWR, same curb weight, and you drive them around for a week. The V8 will use significantly less fuel than the four-cylinder because the four-cylinder is having to use a lot of fuel and a lot of air to make that 225 horsepower, whereas the V8 engine is sipping on fuel to make that 225 horsepower. Okay? That's how internal combustion engines work. If you make an extremely powerful engine and then you limit it to run at only 15-20% of its capacity, it's going to use less fuel than a 1-liter four-cylinder engine that makes 200 horsepower and has to use all of that capacity every single time you use it.
first generation Dakota package and price it like in the $18,000 to $20,000 range so that the average
Nothing is $18,000 to $20,000 anymore, my guy. It's 2024. Get used to the economy being this fucking shitty.
person can use it and the average worker can throw his tools in the back and head to the job site. Not everybody has to pull down a frickin' castle with their giant huge pickup truck. Some of us could actually use practical sized work trucks with
It's no bigger than a Ram 1500, which is a practical size work truck with a standard bed length. And me personally, when I buy mine with my employee financing and employee discount, I'm going to be using it to tow a 29-foot trailer. So your argument here is kind of falling apart, bud.
practical power plants. You want to make it electric? Go ahead, make the damn thing electric.
He failed to mention that this thing makes 700 horsepower.
But this is pure absurdity. I guess this, at the beginning, this as a Mopar guy, this is an embarrassment. I've said it before, but I say it again. And every time I say it, I mean it even more. Dodge, Mopar, Chrysler, whatever it is, Stellantis, you belong.
It hasn't been Stellantis in like 15 years. Stellantis has had nothing to do with Mopar for a long time. It's currently owned by Fiat Chrysler of America.
In the Dust Bowl of history. That's it. Done. Pull the plug. You've dragged the Chrysler legacy through this.
So I'm going to end it there. It's a little fucking ridiculous. So again, let's recap here. So the RamCharger is using an established engine with massive parts availability. The engine has been in use for 20 years, so everybody knows how to work on it. I can replace the oil cooler assembly with my eyes closed, drunk, and high. There's that. I've done so many of them. I know where every single bolt is. I know how to get to every single bolt. I have a package of extension and wobbly bits to get to the two 10mm bolts that hold the part of the intake manifold that droops over the forward valve cover. I have a setup just for taking those two bolts off so that I can just easily lift the valve cover off. Okay, I've done a lot of these. So, reliable engines, people know how to work on them. There's parts for them everywhere. They didn't start as reliable engines, by the way. I know what you're going to say. It's going to have all the parts of a normal engine. Yeah, well, so will a generator. That's how they work. That's kind of how internal combustion engines work. They need shit to run. Generators don't produce electricity by magic. That's just, oh God, it's so much. But the RamCharger is a battery electric vehicle that has a 20 kilowatt generator built in. And it uses the Pentastar for all the reasons that I just listed. And because It can generate 400 plus horsepower, but it's only going to be using about 125 to 175 depending on what they use for the actual generator itself. So it's going to sip fuel, meaning this is from Dodge. It has a 700-mile range. That's impressive. It's extremely impressive, actually. It's going to have, I believe, they've bounced around on the number thus far, but the last thing I saw settled on was an 86.5 kilowatt hour battery pack in addition to a 20 kilowatt generator. So, as far as is this a gimmick and where else has this been used? Diesel locomotives do the same thing. They have nickel metal hydride battery packs. They have a V16 diesel engine that's only connected to a pneumatic air pump and a generator. The Fisker Karma EcoSport, which used a Chevy Ecotec 2.2 liter 4-cylinder engine to spin a generator on this very, very, very tiny 2-door Corvette looking vehicle. Ferdinand Porsche used it on the Tiger P and the Elephant tank destroyer. Really hasn't been used a whole lot of other places. With the U.S. military, General Electric is going to be doing this with the Abrams X, which is the Abrams 10. It is the MBT that is currently in development by the DoD. They will be using this technology for the new Abrams tank because when you're at war, you kind of have limited access to fuel. The series hybrid fuel system makes things more efficient. Period. End of story. So, I just... people like this just really shouldn't speak up about things that they've never worked with and have no idea on. It is quite frustrating that these are people that individuals look up to, and they see videos like this and they go, well, that's just fucking stupid. I ain't going to buy me a damn Ram ever again now. So, okay, talk with your money. That's how capitalism should work. But at least do it for the right reasons. I have said for the past 10 years as an automotive technician that battery electric vehicles were not the future of the automotive industry. They never were going to be. I've always maintained series hybrid is the way that everything is going to go. And it doesn't have to be gasoline hybrid, but a series hybrid is the way that everything is going to go because it is the most efficient thing. Because here's the thing about internal combustion engines. Currently in automobiles, we have engines that need to create power from 750 RPM all the way to their red line, 5,500, 6,500, 7,700 RPM, whatever. They need to make horsepower and torque all the way through that rev range. So we have to design the crankshaft balance to be mostly in balance throughout that entire RPM range. We have to, and this is why we have cam phasing and variable valve timing, is because we have to make the camshaft lobes, their lift and duration has to be able to produce that power all the way through the rev range. Everything about the engine has to be designed to make power throughout the rev range. If you take a 5.0 Coyote Mustang and a 5.0 Coyote F-150, the heads are going to be very different. The intake and exhaust ports are different sizes. The intake manifolds are different lengths. Technically, I don't know if that's actually true. I've never compared one side by side. The exhaust manifolds are different. The camshaft lift and duration is different. The crankshaft is different. It's all different. Cooling system's different. Because in the Coyote, they want it to make high-end horsepower, or the Mustang, they want it to make high-end horsepower. In the truck, they want it to make low-end torque. So these are all things that you can change on an internal combustion engine to decide where they make power and where they're most efficient. The Ford F-150 with a 5.0 Coyote is going to be more efficient at low RPM highway cruising, whereas the Mustang's actually going to be a little bit more efficient in a higher RPM than the overdrive cruising on the freeway RPMs. The same thing can be said about series hybrid engines. Rather than having to deal with a rev range from 750 to 6,000, you now get to pick one RPM. So if you're using a permanent magnet synchronous AC motor, the rotor speed dictates the voltage. So let's say on this permanent magnet synchronous motor, we get 600 volts at 2750 RPM. Okay, Our engine now only has to run at 2,750 RPM, period, end of story. It's either idle or 207,050 RPM. Doesn't ever, ever, ever change RPM, ever. Well, now we can adjust our crankshaft balancing to be perfect at 2750. Our exhaust header design can be designed to scavenge exhaust pulses perfectly at 2750. Our exhaust ports can be designed to give maximum torque at 2750 RPM. Same with the intake ports and the length of the intake manifold runners. Our camshaft lobes, the lift and duration, can be designed exactly perfectly for 2,750 RPM. No more variable valve timing, right? The fuel injection can be designed perfectly for 2750 RPM. The cooling system can be designed for the thermal load at 2750 RPM, not more, not less. The oiling system can be designed for the third system vibrations and wear at 2750 RPM, and nothing more, nothing less. So now we've taken this engine that's maybe 43% efficient and we've bumped it up to maybe 87% efficient, because every single little thing about the engine was hand tailored to 2,750 RPM, because that's all we need. That's everything. That's the only RPM this engine should ever realistically see. So we can make it work perfectly at this. It will barely use any fuel to maintain this RPM. Loading the engine down won't be as easy as a typical engine. So a series hybrid electric vehicle is absolutely, primarily because of this, absolutely the most efficient system for propulsion you could ever have in a vehicle with current technology. Now, know that I say current technology because tomorrow somebody could come up with a new type of fusion reaction or fission reaction that is more efficient and is smaller, could be put inside the car, is safe, not volatile. That could be the car technology of the future. But guess what? It would still be a type of series hybrid battery. You would be generating electricity by the burning of fuel. In this case, either the fusion or fission of certain materials, uranium, plutonium, cesium, what have you. We're using that as a long-term fuel, burning that fuel to create electricity, whether it's by thermal energy, whether it's, maybe someone finds a new element who radiates electromagnetic field. We can capture that and use it to charge the batteries and power the wheels, what have you. It still technically would be a series hybrid system. And series hybrid systems are the best option. They are the most efficient. They are the least polluting. They are, period, end of story, the future of the automotive industry. Whether you like it or not, whether you agree with it or not, Mazda is working on one that uses a 660cc rotary engine to spin a generator. Ford is working on one. I don't know any details about it specifically, but I believe it's going to be piloted in the Explorer or the Escape. Volvo is working on one. BMW is working on one. Mercedes is working on one. Fiat is working on the RamCharger. Go figure. Vauxhall has one. I think they did it a few years ago, though, and it's not. It's dead. It's not coming out. General Electric in the United States military is working on one. There's that. So, as you can see, it's starting to transition away from pure battery electric to series hybrid technology. So, I've got nothing else. I'm kind of done tearing this guy to pieces, picking him apart. Like I said, if he sees this and he finds anything offensive, I don't know what to tell you, because that is what you open. I'm going to open myself up to the same kind of reactions from people that know less than me or people that know more. I'd like to see that happen. I wish Engineering Explained would tear apart my video and tell me on the specific parts that I'm wrong, because I'm one of those people that's interested because I want to learn. But this guy, just the amount of misinformation that he's putting out there is fucking ridiculous. So if you want to see more videos like this, you want to see more talk about electrification, about the automotive industry, go ahead and give me a follow. Like I said, I am a level A technician. I've been in the automotive industry for 10 years. And this is what I do every single day of my life. This is how I've paid to raise 2 kids. This is how I've kept my wife happy. This is how I've bought dumb shit like all this RC plane stuff, which ironically all uses battery electric. That was a cheap shot. But this is now at an hour and 5 minutes. If you have stuck with me this long, let me know in the comments. If you've stuck with me this long, you better be pressing the thumbs up and hitting subscribe, because I swear to God, I will hunt you down and find you and do it for you. And I won't make it weird. So hopefully I will see you guys on the next one. Thank you for tuning in.